Hello, class. This hopefully is the last of the recorded lectures for section 6.1, and we're going to focus on expected value and the calculation of variance and standard deviation on these probability distribution functions. Probably the most important concept in this section is this idea of expected value. This is the idea of how probability is used in real world applications. So that's why I mean by it being important. And insurance companies use it all the time. So what insurance companies do is they'll take a variety of different variables and analyze those variables and how they affect people's behavior. And so for like auto insurance, as you know, when you're younger, your insurance is more expensive than when you're older. Actually, when you're younger, males pay more than females because males get into more accidents when they're younger than females do. Also, depending on where you live, the value of your car insurance would change. When I lived in Batavia for a while, and now I lived in Chicago, and that aspect of more accidents and more people in Chicago actually affected my insurance as well. And so all these variables get put into a probability distribution function, and they do a calculation on an expected value. And so what they do is they'll do an expected value calculation on how much money they have to pay out. And they'll make sure that they charge people enough money that they bring in so they don't lose any money. So it's a very important calculation. And so let me show you the slides here, and we'll walk through one of them here. And so this is an example here, this expected value. And when you do expected value, you could hit negative or positive at the end of it. If it's positive, then you're actually making money. And if it's negative, you're actually losing money. And so here's what I mean by a simple example for insurance. And so this has the idea that the insurance company is charging $200 per person, making it pretty simple. And the idea that 1 out of 50 people will make a claim of $2,000, 1 out of 20 people will make a claim of 1,000, and 1 out of 10 will make a claim of 500. So how do we set that up in a little table here? And that's the wrong thing. Sorry for my big face showing up. And so let's set up a little table here. So we set up a little table, and we have our X value here is we have $500, right? $1,000 claim and $2,000 claim. And what's our probability distribution function? Well, it says 1 out of 10. So that would be 0.1. And then we have here 1 out of 20. And that would be 0.05. And then we would have 1 out of 50. Sorry for the pause there. I was trying to get my calculator, and that would be 0.02. So then what you're doing is you're calculating expected value. That's another term for what we like to talk about in statistics as long-term mean. And so how do we calculate the mean? Well, this would be 500 times 0.1, right? So this would be X times P of X. So actually expected value is calculating the mean. And so this would be 50 bucks. And this would be 1,000 times 0.02. And so if you did that, oh no, 0.5, sorry. Copied that number wrong, 0.5. And if you did that, that would be another 50 bucks. And then if you did 2,000 times 0.02, that would be $40. So our mean of this, or expected value, another term that's used as long-term mean, is you add this all up and you get $140. Well, the original problem asked you, what happens if the insurance company charges $200? Well, if they charge $200, the expected value is the money they bring in, which is $200, where minus the money that will go out for the accidents, and that ends up being the difference between the two. So in this case, we have 200 minus 140, and that would equal 60 bucks. So another fun problem is, I don't know if you remember the show Deal or No Deal. That was Howie Mandel, where they had all these cases with dollar values in there. And so what you did is you picked one of the 30 cases and then you started opening up cases. And this banker would call down and offer you money for your case. And basically what they were doing was calculating the expected value of what cases that were left, and then would lowball you a little bit to try to buy that case from you. And so here's an example. I wish we were together because we would play a game, but we could just talk about it on the slide here. So say like there are 5 cases left, 100, 400, 1,000, 50,000, and 300,000. So what is the expected value of that group of cases? So the first thing you got to realize is the probability of each one of those cases occurring is exactly the same, right? It's kind of like rolling a dice or flipping a coin. And so we have 5 cases left. So the probability of each one of those cases that you have, right, if you had one of those 5, would be 1 out of 5, or 20%. So the way you set this up, again, is you set it up in the table format. And here we have our 4 values, right? And so this is our X. Our second column is our probability, which is 1 out of 5, or 0.2. And our third column is multiplying the X times P of X. And so if you do all that, you can see that the big one down here is 60,000, right? But if you add all those up, the expected value would be 70,300. So what they would do is, dramatic, Howie Mandel would pick up a phone and theoretically there's somebody telling him a number. And so they would usually lowball the number. And so they would probably offer something like 50,000 or 45,000 or 55,000 and want you to take it. If not, you would open up another case. So all carnival games are set up with expected value calculations. So, and again, if we were together, I'd have a bag of Skittles and we would play another game, but it's nowhere near as fun on recording. So I'm going to skip that part. So the last thing we're going to talk about is this calculation of variance and standard deviation. And standard deviation is a more important value than variance. The book tends to say calculate variance and take the square root. I usually do it the opposite, is I'll calculate the standard deviation, and if I want variance, I'll square the standard deviation to get the same thing. But you can see it's the same idea of this process, is that once you have the mean idea, you subtract those 2 and you square it, and then you multiply it by the probability distribution function. And so what I'd like to do is walk through a complete problem. So let's walk through this example. This is not from the book, but this talks about a team soccer games and the probability of playing 1 game, 2 games, or 0 games in 1 week. And you could see the probability of 0 games is 20%, 1 game is 50%, and 2 games is 30%. Converting that to decimal, that is our probability. And here are our random variables, and it's just playing soccer 0 days, 1 day, or 2 days a week. So you could see that here was our calculation where we multiply the random variable times the probability. And you could see when you do that, those are the values that you end up getting. So when we take a look at that on the whiteboard here, I wrote all that down already. And you could see that if we add all this together, this ends up being the mean. And the mean ends up being 1.1. So the question is now, what do we do with regards to the standard deviation? Well, you remember we had this equation here. It was x minus the mean squared. And so I usually set that up that way. And then you need to multiply it by its probability function. So it would look like this, times p of x. So it's a little strange, but you see how you could split it up into different ones. So this would be 0 minus 1.1 squared. And this would be 1 minus 1.1 squared. And this would be 2 minus 1.1 squared. So here, calculator comes in handy. So this would be 1.21, and this would be 0.1 squared. It'd be 0.01, and this would be 0.9 squared, and that would be 0.81. So the next step now is you'll take that number of x minus the mean squared and multiply it by the distribution, which is 0.2. If you do that, this one would be 242. And then if you take 0.01 times a half, it would be 0.00. Whoops, too many zeros there. It would be 0.005. There is 2 zeros, sorry about that. And then this one would be 0.81 times 0.3, and that would be 0.243 in this case. So then what do? Is you add all these together. And when you add all those together, you would get 0.490. So what is that? Well, that would be that idea of the book likes to call variance. So that is this calculation right here, variance. And so how do you find standard deviation? Well, when you do the standard deviation calculation, you just square the variance. So if you take that number and take the square root of it, then you would get a number that would be 0.7. And so these are also in the slide here. So you see that they're available. And you'll also see that the book does a pretty good job of walking through calculator and how you would use your calculator to do some of these variation calculations with regards to that. What I will do is show you how to do it on a spreadsheet. Okay, so this is problem number 13 in the Alex homework. And what I'm going to do is to use this as an example to walk through a spreadsheet calculation of everything we did so far. And so here, it's the beauty of this is it just downloads it right to Excel. Let's see if it does it. Yay, it does. And so make that bigger so we could see it. So you don't even have to type it in. So there's the number, and that's the frequency, right? And so this is our random variable. So I'm going to change that to X. And this is how often that variable occurs, right? So what would be P of X? Well, P of X is that probability, right? And the probability would be, here's our total, and this is the occurrence of each. So basically what you want to do is you want to set that up for a probability. So it'd be equal that number, which is 27. So I highlight that cell, and that would be 822. And you can see we get a probability distribution function. So in this case, we copy and paste all that down. And there you go. What does this have to equal? Well, better equal 1 or we did something wrong. So let's just do a quick sum. And you can see now it equals 1. So here, the next one, so we can calculate the expected value or the mean. It would be X, so the value times P of X, right? And so to do that, we set up an equal sign, and it's this number, and then you hit times that number, right? So it'd be 0 times 0.03. And again, the beauty of this is you can copy and paste the formulas, and away you go. So fast, so nice. So what is our expected value? Well, it would be the sum of all this. We add all that up. Our expected value of this is 1.56. And you would think that it's going to be between 1 and 2. You see where all those values are stuck between 1 and 2, right? 434 and 1 and 263 and 2. So you look at that and says, kind of makes sense, right? So what is the next step with regards to the calculation? Here, I just want to go back and make sure I don't screw this up because I don't memorize all these formulas. That's right. So we have to do X minus the mean squared, and then we multiply it times the probability distribution function. So this would be X minus the mean, and we'll square it. So when you do that, you would have equals, so the X value is 0, right? And then we want to subtract the mean, which would be here. And let me show you a little trick. And I showed a couple of the students after class. But if you want to click on a cell that won't change when you copy a formula, you just hit F4. And then these dollar signs go in there, which means when you copy and paste something, that keeps that cell value the same. It doesn't change it, which is really cool. And then you do the square, which is shift 6, 2. And there's our calculation. And so there's our value there. Next step is you copy this, and now, and you could do this in one cell if you like. If you do it by hand, it's usually easier to do two, because then you want to multiply this by the probability function. So in this case, it would be equals that cell there times the probability, which would be C2 there. And there's your number. And then you copy and paste it. And so if we add all this up, that would be our variance. And what's our standard deviation? Our standard deviation, this is our variance. Our standard deviation would be the square root of this number. So you could use the square root function, or for me, it's easier just to take it to the 1/2 power. And so you could see that the variation is almost 1, right? 0.86, the standard deviation. And yeah. And so with regards to that calculation there, you can see hopefully That spreadsheet gives you just a very good uh, tool. I couldn't think of that word to be able to do these calculations. Man, try to do this one by hand, and even though there's only 5 numbers, it would take you probably 10 times, if not 50 times longer than what I did right there. So hopefully that helped. And that ends the recorded lectures for section 6.